All right, so I'm doing a coding challenge, K difference. Again, this is one of the ones I did yesterday that I was able to actually finish, but it definitely took me longer than it probably should have. So I'm going to redo it now. All right, so we're going to go with 15 minutes on my clock now. All right, so this problem is what's called K difference. You're given an array of distinct integers and another number called K. You're supposed to return the number of unique groupings of K from the given array. Order here doesn't matter. So for example, if you have this array 1, 3, 5, 4, 2, and K equals 2, K difference I should say, K equals 2, then you're looking for any pairs, so they're all going to be pairs. You look for any pairs that have a difference of 2. So like 1 and 3, 3 and 5, and 4 and 2 are those distinct pairs. And the order doesn't matter, so 4 and 2 and 2 and 4 are going to count as the same. What I was originally thinking was I would loop through all the possibilities. Of course, that's kind of a brute force thing. So if I do something like loop through, so I would say iterate through each number looking for complement in rest. Okay, so that would definitely work. And I guess I would increment a counter. So all you need to do is have a count. So you don't need to actually know what those numbers are. So this would definitely work. It's just this is what O, this big O of n squared, or yeah, n to the second, right? Because you have to go for each one. You're going through each one, so it's n. It's literally n squared. So that is not ideal. But it would technically work. So how can you make this more efficient? Well, one thing I was thinking was you can store in memory. So keep complements in memory. So this is a classic like trade time for space. You know, so I'll be keeping these things. Each time I go through each one, I will check to see, hey, is this complement needed somewhere else, and then if not, then add your own complements. The trick here though, and I didn't realize it at the time, and I really should have thought more about this, was what happens in the situation that you get like so right here, so you have like the 1 and the 3. Well, if you count 3 here, so if you count 1 and 3, that counts as like one pairing. Using this algorithm that I just mentioned, by keeping it in memory, so here, I'm going to write more explicitly. So keep the complement in memory, check for, so loop through each and check if in memory. And these are complements. If so, increment by 1. So add complements to memory. Oh, the problem was, but a situation where this happened, where you had, so this is like a, kind of like a bad case here, where if the 3 is coming later, if the 3 comes later, it's only going to find one complement. This one or this one, but it's not going to count as 2. So you have to remember, wherever you find a complement, you have to like keep track of the number of complements, and that was my problem that I wasn't doing. So this would be O of n. So that's actually nice. So I'm going to try that one. And let's just do this. Let's code it out. So function kdiff, I'm going to call it, and you might give it k. And so this code looked like kdiff, and let's give it this thing. Oh, you're giving it an array as well. Sorry, our array that. Okay. R and then k is 2. Okay, so that's my test. One of many tests, I guess. Right, okay, so how would I do this? So I'm going to have my, I'm going to actually loop this thing, bring it in. So keep everything in memory. So let's do that. Const storage, or you can call it complements. I'm gonna keep it as an array, or sorry, as a object, or hash map, whatever you want to call it. And then loop through each, right? So for const num in R, or is it of? I think it's of. Of that, here we do our check. We say, okay, if complements has the number, then we will. If complements has a number, then we will say, okay, total is incrementing. So we will, in the end, return total. All right. So if the complement is there, then we must. I'm using a hash map because I know, like, oh, if you've seen it before, but you need to make a count for all the number of complements that are associated to that complement. The number of complements associated with the complement. So, for example, with the 1 and the 5, they both share 3 as a complement. So when 3 shows up, if you don't count 2, then you're going to be missing 1, basically. So that's why you need to have add both. I have some way of like storing the idea that you have 2 that are in memory. All right, so that's why we use a hash map. If complement num exists, then my total is literally adding to whatever was found. Else, if it doesn't exist, then we will create it as 1. And then we need to add the complements too. So this is like the lower complement, and this is the higher complement. I'm just going to copy this, basically. It's not much different here. So I'm going to say this is like const lower equals num minus k. And so I'm just going to replace lower with all this stuff. Complement being lower, I just add 1 to whatever it is. Actually, I should check. If complement lower doesn't exist, then set it equal to 1, else add 1 to it. And the same thing with upper, higher complement. So it's going to be higher, and that's num plus k. Okay, so let's see if we can run this thing. This is going to be kdiff. It gave me the number 3. So that was what I was expecting. So this worked. And let me cut my time. Okay. 4 minutes and 27 seconds. Man, there is like no time to waste on this thing. So you really, like, you're gonna have to like know your stuff. I'm just not accustomed to doing these coding challenges in like 15 minutes and not having time to like look up answers and look up methods and things like that. So and usually the way they word things, it's not, you don't need to like have outside help. It's just like solve this challenge. So I hope that was enlightening or helpful. I'm gonna be tackling, so these are the 2 that I did get yesterday. So these are like, so Fibonacci and the kdiff, I got those. Took me a while. I think in total it took me for like 45 minutes. I would say, like, it took me a long time to just get through this. No, maybe not 45 minutes. Actually, I think it took me about half an hour, to be honest. It took not that much time. The third one killed me though. That one took forever, and I still didn't get the answers. I'd say it had like 2.5 out of the 5. So anyway, hope that was helpful, enjoyable. I'm gonna go to the next one. I'm just gonna be plowing through these all day.